In this video, I want to talk about the naive Bayes model. So we'll start with describing the dataset. So the dataset is email data. So here, for example, is the first email. So it has the words dog, homework, and 8 in it, and it's of class 1. Okay. How are we going to write it? So we can write it as dog, homework, 8. But really, we want to write it using this encoding, right? So here, I just numbered all the words that appear in any email. So we'll say that x0, it's really, so dog appears there. So that means that x0 is going to be 1, and homework appears there. So x1 is going to be 1. So this is x0, and this is x1. And 8 appears there, so this is a 1, but college and Canal do not appear in it, so it's going to be 0 and 0. So this is x2 and x3 and x4. Okay, so this is just how we're going to encode this. Now we're ready to state the naive Bayes assumption. So the naive Bayes assumption is basically that the x's, so those 1s and 0s, are conditionally independent of the y. So we'll say that the probability of x given y is just going to be the product of the conditional probabilities for the individual components of the x. So this is going to be xi given y. All right. So what does it mean specifically? So here, for example, it means that the probability of this vector, so the probability of 1, 1, 1, 0, 0, and this is going to be the x, given that y is equal to 1, well, that's just going to be this product. It's going to be the probability that x0 is equal to 1, given y is equal to 1, times the probability that x1 is equal to 1, given that y is equal to 1, times and so on. And the last thing is going to be, so 0, 1, 2, 3, 4, the probability that x4 is equal to 0, because here it's 0, given that y is equal to 1. Okay, so that's going to be the probability of this x0 given this y0. So, okay, the last thing I want to do is I want to actually compute the probability of this data point. So that's not the same as computing the probability of this x given this y. The probability of this data point that's given the parameters of the model. What's the probability of observing this kind of email? Okay, and the parameters of the model are what we discussed when we discussed learning the naive Bayes model. It's the probability of the y being 1 or 0, and it's the probability of each keyword given y equals 1 and given y equals 0. So, okay, what is the probability of observing this data point? In other words, what's the probability of x is equal to 1, 1, 1, 0, 0, and also y is equal to 1 under the parameters of the model? Well, we already have this, so we can use it. So we can say that that's just equal to the probability of x is equal to 1, 1, 1, 0, 0, given that y is equal to 1, times the probability that y is equal to 1. And this you can compute using this kind of product. And this you can compute by looking at the probability that y is equal to 1. How do you think about a formula like that? Well, you say when we're generating this kind of data, what we'll do is we'll first decide, well, is the email going to be spam or is it going to be non-spam? With probability t of y equals 1, so with this guy, which we usually denote with something like pi 1, we'll say, okay, this email is going to be spam. And now you're going to say, okay, so given that the email is spam, what kind of keywords are going to appear in it? And the answer is, well, this is going to be governed by those kinds of probabilities. So if you want to compute the probability of x0 being 1, x1 being 1, x2 being 1, x3 being 0, x4 being 0, then you just need to multiply all of those things, and that's going to give you the result. So if this product is large, then the keyword combination is likely. If the product is small, then it's less likely. Okay, so this kind of thing, that's a parameter of the model, just like this is a parameter of the model, right? So you can call it something like theta 0, 1. So the probability of x0 being 1 when y is equal to 1. In the same way that you would call this something like theta. So here, this is x4 is equal to 0. So you would say, okay, so theta 4, 1, and that's the probability of x4 being equal to 1. But you can just subtract that from 1, and you'll get the probability of x4 being equal to 0. So those are the parameters of the model, and they determine the probability of the data point. If you want to compute the probability of the entire training set, so that would be kind of like the likelihood of the training set, you would say, okay, so the probability of x0, y0, and x1, y1, and so on, well, usually assume that the data points are independent, so you would just say that that's the product of the individual probabilities. All right, and that's the naive